File system caches. And I started with the Solaris one, and it's the same on a Lumos. And this gives you an idea of all the different caches that currently exist. There's lots. There's I guess I did this first because this is the history lesson that is our Illumos kernel. The Illumos kernel has swapping, which is like ancient, and all sorts of different things over time. This is really a walk through time for the different cache types. The buffer cache was the first cache in Unix. The buffer cache was associated with each disk device, and originally it was only like 40 elements in size or so, but it allowed any recent access to disk to be cached and improve performance. And in original Unix, that's all we had was the buffer cache. That was it. BSD then added the page cache. And so the thing about the buffer cache is that it is indexed in terms of disk offsets. Okay? The page cache is indexed in terms of files and file offsets. And these are very different. And so there are different policies for caching things. The page cache has, and so with the page cache you can do things that you can't really do with the buffer cache, or at least with file systems working with the page cache. Once you're looking at the indexing of file access, that's when you can do things like prefetch detection, which doesn't work so well at the disk level because the disk itself may have scattered that file offset. If you're watching the disk accesses, it looks random, but then if you look higher up at the VFS level, that's not random, that's just this is one file that we're stepping through. So anyway, just to give you an idea that these are different ways to cache data, and different workloads can be served better from one or the other. Both of them still exist in Illumos. We still have the original buffer cache and the page cache. We have an inode cache for UFS, is in the buffer cache. The page scanner is actually what drives the page cache, at least for evictions. We have a directory name lookup cache, so that when you access long path names, it doesn't have to go and step through the entire directory and each of those components. It will map a full path name straight to the file object, which is going to be a vnode object, which is an abstraction of the file system objects. Okay, so I kind of get that stuff. Then there's ZFS, which has its own cache, the ARC. And in ZFS there's another thing called the VDEV cache, which works a bit like the buffer cache. VDEV cache is for ZFS virtual devices or disks. And so two different cache types. The VDEV cache is small, the ARC is very big, and the ARC is similar to the page cache. And then there's the ZFS L2 ARC, which I developed for the second level of cache, which the primary use case that we intended this for is flash memory. So I can put flash memory in my system, and it extends the reach of DRAM. Cool. Something that might help you clear up some confusion with all of this is, why do we have so many caches? This was unified with the page cache, so these are kind of the same thing now. But if the ARC is so great, why don't we ditch the page cache and just use the ARC for everything, and ditch the buffer cache and just use the VDEV cache for everything? And the answer is, yeah, we probably should. When Sun developed ZFS, you can imagine the test framework. If my project is to integrate a new file system, which has its own cache, fine, and ZFS had to go undergo millions of tests, it has its own test suite, versus if I'm an engineer working on a project and I'm telling the gatekeepers, no, we're not just doing a file system. While we're doing the file system, which is hard enough as it is, we're also going to rip out all of this stuff. It's like that actually would have made ZFS take a lot longer to be developed, because I'd have to test all sorts of consequences with UFS and weird parts of the kernel that hadn't been tested for a long time. They should have done it, but practically they did this in stages. So we got the CFS got put in first, and then a later stage was to do some tidy up and probably remove those things because we just have the Arc.
Is UFS still used by anything?
We use it for our boots. Do we use it for our boot devices, boot sticks? Boot archive is UFS. So the work hasn't been done yet to ditch the other ones. Maybe one day it will be, and this will become simpler. But at the moment, it is a bit of a tour through Unix, BSD, and Solaris. So, gee, if we port this all to Linux, then we can throw a Btrfs cache in there or something. That wouldn't really work. It's too much kernel code. So I then have sections in more details, but for these purposes, we just needed to understand why these all exist. And it's helpful for me to tell you that there's not a great reason they all exist. They do exist. And maybe one day it will get a bit better. So I've got notes on the... So originally, the buffer cache and the page cache was separate, and then Sun unified them. Sun unified them into the page cache, and the APIs that used to call into the buffer cache or used to call into the page cache, they were then managed by these interfaces called segmap and segvn. So if you've seen those terms before, and you will eventually run into them into the kernel, that's why. These were necessary as API front ends for the unified page cache that we now have. So a notion of a buffer cache still exists, but it's really the same storage as the page cache. It's a different interface to the page cache. Then I talked about the DNLC, the directory name lookup cache. I've had the Linux caches, which is a bit simpler.